Okay, this video is about polynomials and finding the zeros of the graphs and graphing sketches of these polynomials. So what we need to do to be able to graph them is we have to get this original polynomial into factored form. So our goal is to get it as a bunch of parentheses like that and have it completely factored. What I'm telling you in these problems is this second binomial is one of those factors. But what we have to figure out is what the other missing ones are. And so the way we do that is because we know that this blue one, x minus 3, is one of the factors of the yellow polynomial, we can divide it, and then it's going to make the polynomial smaller, and it's going to make it easier for us to factor and break down. So we're going to start by doing synthetic division. And because it's a binomial that we're dividing by, I set it equal to 0 and put positive 3 in here, and then write my coefficients, -1, -2, 15, and my constant is 0. So I carry my -1 straight down, multiply and get -3, add and get -5, multiply and get -15, add and get 0, multiply, add. Okay, so now I need to rewrite the yellow in its factored form. I factored it a little bit. So since it started here with a cube, I know my answer is a squared, so that's -1x squared minus 5x, and then I don't need to write the plus 0, and my remainder is 0. So that is that part. And then I'm going to make a new parentheses with the other part. So I'm rewriting it as a multiplication problem. Okay, well, it still can be factored more because this polynomial right here has a greatest common factor that I can factor out before it's completely factored. And that greatest common factor is not just x, but -x, because remember when we factor, we want the leading coefficient to be positive, and right now it's negative, so we have to take out a -x. So when I take out a -x, -1x squared divided by -x is just positive x, and -5x divided by -x is positive 5, and then I have x minus 3. Now I need to figure out the zeros of the graph. And to find the zeros of the graph, it's like you're solving a factoring problem. I need to set all of these equal to 0. Well, x minus 3 equals 0 is just 3. X plus 5 equal to 0 is just -5. This one here tricks people, but you can't put 1 there. If I put 1 there, I've got -1 equals 0. That's not true. The only thing that works is 0. Okay, now that I know the zeros of the graph are where the graph crosses the x-axis. So I can go ahead and plot those on my graph. So I've got 0, -5, and +3. And no, you do not need to write those equations out. I just wrote them because it was on a video and I want to help clarify. Okay, so now we got to figure out the leading coefficient. So I'm going to look at my yellow polynomial. The leading coefficient is -1. The degree, which is the highest exponent, is 3. So that makes it odd. Just kidding. That makes it negative leading coefficient and odd on the degree, which means it's going to go down on the right and up on the left. So I'm going to go down on the right and up on the left. Once I know that, all I need to do is weave my graph around. All right, let's try this again on the second example. So again, we're trying to write it in factored form, and we know one of the factors is x plus 2. And to figure out the other ones, we're going to do synthetic division. So I'm going to put -2 because I set this equal to 0, and I've got 1, 3, -10, -24. Everything was used, so I don't need any placeholders. Carry my 1 down, multiply, add, multiply, add, multiply, and add. When you are doing this, because this is one of your factors, your remainder is going to be 0. And if it's not 0, you've done something wrong. Okay, this started with a cube, so this has got to be squared. So I've got x squared plus x minus 12. And I can take that times what I knew my other factor was, which is x plus 2. And now I can factor this x squared plus x minus 12 more. It's a trinomial. The leading coefficient is 1, so I'm going to go straight to my 2 parentheses. And the two numbers that multiply to -12 and add to 1 would be 4 and -3. And then I've got my x plus 2. So now I've got my zeros are -4, 3, and negative 2. If I look at my original yellow polynomial, the leading coefficient is 1 and the degree is 3. So this is positive and odd, which means I'm going to go up to the right and down to the left. If you don't know how I'm getting this from the chart. You have to know the chart. Okay, so I'm going to plot the zeros on my graph. So I get negative 4, 3, and negative 2. I know it's going to go up to the right and down to the left. Then I'll just weave my graph in, and there we are. Okay, notice that this one, the zeros of the graph, there's 1, 2, 3 of them, and the degree is 3. That's not a coincidence. The amount of zeros has to match the degree. All right, let's try this one. So we want to get it in factored form. They've given us one of the factors is x plus 1, so I'm going to use synthetic division to break it down a little further. So I'm going to put negative 1 right here. So now I got 1, 2, negative 5, negative 6. My constant is 0. Bring the 1 down. Multiply, add, multiply, add, multiply, add, multiply, add. All right. So be careful how you write it this time. This one right here, it started as x to the 4th. So my answer has to be 1 degree less. So my answer is going to be x cubed plus 1x, x squared minus 6x times what a given factor was of x plus 1. All right, now I need to factor this trinomial. Well, yes, it's a trinomial with a leading coefficient of 1, so I can think about what multiplies to 6 and adds to positive 1. But I have a greatest common factor here, and I have to do that first. And when I take out the greatest common factor, it's a two-part problem. So first, I take out the greatest common factor, and then I can factor the trinomial. You can't do it at once. You'll make mistakes. So the two numbers that multiply to negative 6 and add to 1 would be 3 and negative 2. So I have my x, then this factors to x plus 3, x minus 2, and then I have the x plus 1. So now I know my zeros are 0, negative 3, 2, and negative 1. I can only have a 0 of 0 when I have a single variable. If I have a binomial, it's going to be something else. Okay, looking back at my yellow original polynomial, the leading coefficient is 1, the degree is 4, so this is positive, this is even, so they're both going to be going up. I'm going to plot my zeros, so I have 0, negative 3, 2, and negative 1. They're both going up. And now I'm going to weave it in and out. Okay, let's try one more of these. So I know one of the factors, so I'm going to divide to break it down. So I'm going to put a positive 2 here, 1, 5, negative 2, negative 24, leaving a 0 for the constant as a space placeholder. Bring my 1 down, multiply, add, multiply, add, multiply, add, multiply, add. All right, but when I go to rewrite this, my original polynomial was x to the 4th. So my answer has to be x cubed plus 7x squared plus 12x times the x minus 2. Okay, now yes, it's a trinomial with a leading coefficient of 1, but I cannot go straight to my 2 parentheses on this because there's a greatest common factor, and that greatest common factor is x. So I'm going to take out the x, and then I'm left with x squared plus 7x plus 12 times x minus 2. When I have a greatest common factor, you have to factor it in 2 steps. You can't do it in 1. So now I'm looking for numbers that multiply to 12 and add to 7. So I'm going to have x plus 3 and x plus 4 times x minus 2. So my zeros are 0, negative 3, negative 4, and 2. If I'm looking at my original yellow polynomial, the leading coefficient is 1, the degree is 4, so this is positive. This is even, so they're both going up. I can plot my zeros on the graph. I know they're both going up, and then I'm going to weave it in and out. Now, on these problems, the zeros of the graph, so here the zeros of the graph, they each occurred one time. And so if each one occurred one time, my degree matches how many zeros there are, and it all works out. When they occur one time, one is an odd number. And anytime we have an odd number, the graph is going to cross this x-axis. But now what's going to happen is some of them are going to be repeated. So for example, you can have x plus 3 times x plus 3 times x minus 4 times x plus 5. This is still a degree of 4 because if I multiply this all back out, I'm going to have x to the fourth something, something, something. But this 0 gets repeated. And when it gets repeated, we're talking about the multiplicity. So how many times it occurs is the multiplicity. And based on the multiplicity, changes what happens. So if the multiplicity of a 0 is an odd number, then the function crosses the x-axis. If the multiplicity of the 0, and when I say cross, remember, right here, my graph was above, and then it went below. It was below and went above, so it's crossing this x-axis. But now, if the multiplicity of a number is 0, so if that 0 occurs 2, 4, 6, 8 times, then the function bounces off the x-axis. All right, let's see if we can figure this out. So when I do the first one, it may seem a little bit confusing, but as I do more and you see more examples and compare and contrast, hopefully then it's going to start to make more sense. Now, the nice thing about these problems is they're all factored. The other nice thing about these problems is the leading coefficient on all of them is always going to be 1. Okay, so that means it's always going to be positive. So how are we going to figure out the degree? Well, this parentheses here gives me 1, 0. And this parentheses here gives me 1, 0. And 1 plus 1 is 2. So I have a degree of 2. When I'm figuring out my zeros, I'm going to set each parentheses equal to 0. So I get positive 1 and negative 2. So I can plot that. With my degree being even and leading coefficient positive, they're both going to end going up. Now, as I'm looking at this, because 1 occurs just one time, 1 is an odd number, so it's going to cross. Because the negative 2 occurs just one time, 1 is an odd number, it's going to cross. So when I draw on my graph, it's going to cross the x-axis at both of them. Now let's compare this to what happens in the second one. Like I said, on these types of problems, leading coefficient is always going to be 1. For the degree, this positive 1 occurs 2 times. This negative 2 occurs once, and 2 plus 1 is 3, so my degree is 3, even though my zeros are still 1 and negative 2. Because this is positive and this is odd, I'm going to go up to the right and down to the left. So I know it's going to be like this. But the 1 occurs 2 times, and 2 is an even number. So at 1, it's going to bounce, and at negative 2, it occurs 1 time. That's an odd number, so it's going to cross. So when I'm drawing this, it's going to cross here and bounce off the x-axis here. Okay, a bounce, if you've got a point, a bounce is going to come down and bounce back up. This is a bounce. Okay, if you have a point, this is a cross. All right, let's try the other one. It's going to have the same zeros, but the multiplicity is going to be different. Okay, on all of these, the leading coefficient is 1, so it's going to be positive. This 0 occurs 3 times. This one occurs 1 time for a grand total of 4, so the degree is 4. My zeros are 1 and negative 2. Because the degree is even and the leading coefficient is positive, I know they have to be going up. This 1 0 occurred 3 times. 3 is an odd number, so it's going to cross. This -2 occurs 1 time, which is an odd number, so it's going to cross. So it's going to cross at both of these. So it's going to come down and look like this, which looks a lot like the graph from number 1. And we'll find with the multiplicity of, when the multiplicity changes and there's multiple of them, sometimes these graphs will look similar. They'll have the same shape. Now, remember, we're just graphing stretches, so they can go up further, down further, or change their slope a little bit. None of those things we're taking into account for right now. Okay, let's look at the next one. The degree on all of this type of problem is 1, or the leading coefficient is 1. The degree, there's 4 of these and 1 of these for a grand total of 5. So the degree is odd. It's going to be down to the right, up to the left. The zeros are 1 and -2. Up to the right, down to the left. This 1 occurs 4 times. 4 is an even number, so it's going to bounce at 1. -2 occurs 1 time, so it's going to cross because that's an odd number. So it's going to cross at 1 or -2 and bounce at 1. Again, it looks the same, but it's a different graph. All right, let's see if changing up the numbers clarifies any last confusion that we have. Leading coefficient on all of these is 1. Let's figure out the degree. There's 1 of these. There's 1 of these. There's 2 of these for a grand total of 4. That's even, so they're both going up. My zeros would be -3, 4, and -1. They're both going up. -3 occurs 1 time. That's odd. It's crossing at -3. 4 occurs 1 time. That's odd. It's crossing at 4. -1 occurs 2 times. It's going to bounce at -1. So when I draw them in, it's going to cross at -3, bounce off at -1, and then cross at 4. Now the CBC that I'm drawing on here is not part of the graph. I'm just helping you because you're doing this via video, and I think that might help give you a visual of what's happening. The leading coefficient is 1. The degree is 3. This degree is 1. This is 1. So I get a grand total of 5. That's odd, so I'm going to go down to the right and up to the left. My zeros are 1, -2, and -4. I'm going to go, oops, I did this backwards. I apologize. This should be up to the right and down to the left. Okay. The 1 occurs 3 times. 3 is odd. It's going to cross. So at 1, it's going to cross. -2 occurs 1 time. That odd. It's going to cross. -4 occurs 1 time. That's odd. It's going to cross. So when I'm drawing this in, they all cross. So it weaves in and out. Okay. 2 more. Number 7, the leading coefficient on these types of problems will always be 1. My degree, I have 2 here, 1 here, 2 here, for a grand total of 5. That's odd, so I'm going to go up to the right and down to the left. My zeros are 3, -2, and 5. Up to the right, down to the left. The 3 occurs 2 times. 2 is even. It's going to bounce at 3. -2 occurs 1 time. That's odd. It's going to cross at -2. 5 occurs 2 times. That's even. It's going to bounce at 5. So I got a cross here, bounce, and bounce. Last one, the leading coefficient is 1. The degree is 1, 4, 1, and 2. I add those all together, get a grand total of 8. 8 is even, so they're both going up. My zeros are 4, -3, -2, and 5. All right, when I'm graphing them, the 4 occurs 1 time. That's odd, so I'm going to cross at the 4. The -3 occurs 4 times. That's even. So I'm going to bounce at the -3. Oh, I'm missing a dot. No wonder I'm confused. There we go. The -2 occurs 1 time. That's odd, so it's going to cross at -2. The 5 occurs 2 times, so it's going to cross here. Oh, excuse me. 2 times is even. Oh, now my pen's all weird. I'm going to try and do the last example. Okay. Dang. Oh, there we go. It's going to bounce. My issue was that I put the 5 at the wrong spot. All right, so it's going to bounce at the +5. So now when I graph it, I know both of these are going to have to go up. So at this one, it's going to bounce, cross, cross, bounce. And you get the weird graph like that. Okay, that's it on this topic.